So, welcome to the video on solving quadratics by graphing, um, as well as factoring. So, solving quadratics, just to kind of set the framework for this, there are two basic ways to solve for quadratics. One way is algebraically. Now, there are several ways to solve it algebraically. When I say algebraically, what I'm talking about is isolating x. You'll have an equation, you get the x by itself, and then it's solved. Solving by graphing, there's actually a part of the graphs that we've been doing that's going to be the solution to the equation. So let's go to make this connection real quick. So solving algebraically and solving by graphing, these two are very closely related. So if you think about this equation, we did in a previous lesson graph this. This was y factored form. So in factored form, if you remember, to find the x-intercepts, we set the y equal to 0 because that's where the x-intercepts were. Because when we started graphing, we were looking for x-intercepts first. And then we figured out, okay, if two things are being multiplied and they equal 0, then each part must be equal to 0. So, because 0 times anything is equal to 0. And then we solve these out. They're in parentheses, but you can just drop those. So plus 2 and then minus 4 here. You get x equals 2, x equals negative 4. And then those were our x-intercepts, okay? Now, if you look at this side of the graph, or not the graph, but this side of the screen, you can see that we actually isolated the x's when y was equal to 0. So we actually solved an equation. We solved this equation right here. We set y equal to 0. We had this equation. This is a quadratic equation with one variable because we're not going to solve it in two variables, but in one variable. And then you get the x by itself, and then you're done. That's solving an equation, getting x by itself. Now, it's a pretty easy transition to look at the graph because if you look at these x-intercepts, those are your solutions. So solving algebraically is the same thing as finding your x-intercepts on a graph, all right? So if we take a closer look at solve by graphing, if you have a graph, you're good to go. You just look for the x-intercepts. So if you take a look at this graph and I ask you to solve the equation or solve this quadratic, you would just say, okay, let me look at the x-intercepts. My x-intercepts are at negative 3 and 1, so x equals negative 3 and x equals 1. I didn't give you the equation here, but just note this is a parabola, so it comes from a quadratic. So whatever quadratic this came from, you know the solutions are the x-intercepts. That's all. That's the only thing you really got to look for. So if I give you another one, doesn't matter which way they look, if they're stretched or compressed, just look at it and find your x-intercepts. So take a look at this one. What are your x-intercepts? So you got negative 2 and 6. So whatever quadratic this came from, whoops, that's a typo. X equals negative 2, x equals, this should be a 6. That's not a 5. So whoopsie. I got to fix that. Anyways, so next one, solve by graphing. This one, if I take a look at it, ask yourselves, what is the x-intercept? Hopefully you see there's only one. It only touches the x-axis one time right here at 5. So sometimes quadratics only have one answer, so x equals 5. And it's shown by this graph because our x-intercepts are our solutions. Now, what about this last one? What would your solutions be here? Now, keep in mind, there are no x-intercepts here. And I just told you the x-intercepts are your solutions. So basically, there's no solution. Now, in Algebra 1, though, we're going to say, or actually in algebra in general, we're going to say no real solutions. Because actually there are some answers. They go into what's called imaginary numbers or complex numbers. You do that in Algebra 2. But for now, we're just going to stick with no real solutions. If you put no solution, I may or may not take off points. I might be a little bit lenient, but just know that it's no real solutions because eventually we're going to find out there's actually some answers here. We just don't see them right now. Okay, so quick recap. This is a short video, this lesson. To solve algebraically when it's in factored form, you're just finding your x-intercepts basically. You set each factored part equal to 0, and then you solve for x. That was what we did at the very kind of first slides. It's just like finding your x-intercepts. To solve by graphing, you either make or look at the graph that's given, and then you find your x-intercepts, and then that's it. Now, just a heads up, graphing's super easy if you have a graphing calculator or some type of graphing device. If you have to draw your graphs by hand, you don't have graph paper or straight edge or anything like that, and you know you make really sloppy graphs, solving by graphing is horrible. Because if you make your graph too sloppy, it looks like it's going to have an x-intercept like say at 7 when it's actually at 5. You just drew your graph wrong. So solving by graphing is not always the best way. Now, if you're already given a graph, just look at it and you'll have your x-intercepts. Otherwise, we're going to stick with these solving algebraically, and we'll go over those videos in the future. Okay. If you have any questions, feel free to stop by during my office hours. Otherwise, take care. Bye bye.